Hello, we are JazTech International, or JTI for short, and we provide civil engineering design services for projects throughout the San Diego region and its surrounding areas. Our most recent project was the Carlsbad City Hall and Civic Center. My name is Jesus Espinoza. I was the project manager as well as the traffic engineer on the project.
My name is Zoe McMahon, and my role on our project was AutoCAD lead, and I also worked on the site civil, hydrology study, and the stormwater quality management plan.
My name is Adam Gravel. I designed the utility services for our project, including electrical, water, and wastewater.
My name is Theodore, and I was the structural engineer for this project.
My name is Christian Salais, and I was the geotechnical engineer, and I also designed the Civic Center foundation.
Currently, there exist multiple city offices throughout the city of Carlsbad. This is inefficient for city officials having to drive to all the different offices. This also causes confusion for residents as to which office they need to visit to get their needs tended to. The solution the city of Carlsbad has proposed is the consolidation of all city offices in one location. One of the proposed locations is just east of Interstate 5 on the northeast corner of Pio Pico Drive and Carlsbad Village Drive. On this site, there currently exists a city hall in operation, as well as a library and community garden. JTI has proposed the construction of a two-story, 40,000 square foot city hall and a two-story, 20,000 square foot civic center, and a parking structure to service both buildings. The library and community garden will be relocated within the site.
My primary objective as a geotechnical engineer was to calculate the geological parameters in order to classify the soil layers, determine potential hazards, and make recommendations to other disciplines. To find the soil parameters, I used data collected from a cone penetration test conducted approximately half a mile from our project site. Using the data, I determined that the soil was comprised mostly of clays and silts with a low OCR, and there was no water table within 30 feet of the ground surface. The site can be classified as hydrological soil type D. The site has a high potential for landslides because of the abundance of fine-grained soils. In order to avoid any potential disasters, I recommend that any moderate to large slope should be reinforced with a retaining wall. Due to the high shear stress of the soil, any retaining wall higher than 4 feet should be reinforced with rebars, as tiebacks will not anchor properly into fine soil. The site is prone to seismic activity, and all foundations should be reinforced to withstand seismic forces. Overall, the site has the ideal conditions for the construction of a multi-story structure. The majority of the buildings built on this project location site will be able to use shallow foundations. However, the proposed area of the Civic Center will require deep pile foundations because the first 10 feet underlaying of this Civic Center are made of sand. These driven piles will use number 8 rebar reinforcement and also a number 4 stirrup at a 2-foot spiral pitch.
JTI was retained to assess the potential traffic impacts associated with the development of the City Hall and Civic Center. The industry standard of 50 peak hour trips at an intersection was used to determine the study area. In total, 10 intersections along Carlsbad Village Drive were analyzed, and the encompassing segments as well. The Highway Capacity Manual 6th edition as well as Synchro 10 traffic software were both used to analyze the intersections. The city of Carlsbad uses a capacity of 1,800 peak hour trips per lane for segment analysis and delay and level of service for intersection analysis. The scenarios analyzed were existing, near-term year 2020 and long-term year 2035 with and without project. All scenarios showed acceptable level of service in both the segment and intersections with the exception of long-term scenarios. There were 4 cumulative intersection impacts and 1 direct impact at the intersection of Carlsbad Village Drive and Interstate 5 northbound on-ramps. An exclusive right turn lane with 2 through lanes on the east leg is recommended to mitigate this impact.
The intent of the hydrology study was to effectively carry the runoff associated with the 100-year storm event to outlet points and prevent any severe ponding and flooding from occurring. Based on the 100-year storm analysis, this redevelopment project will decrease the total site stormwater discharge during a peak flow condition from a pre-development flow of 26.95 cubic feet per second to a post-development flow of 16.13 cubic feet per second. Regrading and site features such as new cross-gutters, curbs, and curb inlets will be implemented in order to impede commingling of flows so that the runoff from proposed improvements can be isolated and treated based on current stormwater requirements. By directing stormwater runoff away from building and parking lot surfaces into curb inlets, catch basins, area drains, and landscape areas, the proposed flow rates will not negatively impact the surrounding areas. The purpose of the Stormwater Quality Management Plan is to meet the minimum requirements for managing urban runoff as described in the BMP Design Manual. DMAs needing treatment will be mitigated by installing biofiltration with partial retention BMPs on site. The use of biofiltration with partial retention BMPs will collect stormwater from the proposed improvements and protect the existing storm drain system by removing pollutants and regulating the flow entering the existing drainage conveyance system. Several DMAs were found to be self-mitigating through the use of trees, dispersion, green roofs, and permeable pavement. The proposed BMP areas are adequately sized per the City of Carlsbad standards, and it was determined that the proposed City Hall and Civic Center shall not negatively impact the existing drainage conveyance system.
Due to its ease of constructability and cost effectiveness, we decided to design a reinforced concrete building. The building will be 2 stories tall, include a rooftop garden, and make over 80,000 square feet of office space available to City Hall employees and the visiting public. After a wind and seismic evaluation, it was determined that seismic forces govern the design of the lateral bracing system. The building will be encapsulated by 4 100-foot-long shear walls running the full 27-foot height of the building. The shear walls will provide stiffness to the structure and resist the substantial shears and overturning moments created during abnormal loading conditions. 25 32-inch by 18-inch columns will support the vertical building loads.
As a utilities engineer, I worked on the dry and wet utilities on our project. The wet utilities included the building water service by 6-inch and 4-inch PVC laterals, as well as meters and appurtenances to be furnished and installed by the Carlsbad Municipal Water District at the city's expense. More on those later. Also included in the water side of the wet utilities were 2-inch copper irrigation service lines. These were located around the site at various locations to provide irrigation to the landscaped areas, as well as the community garden on the southeastern corner. The detail on the far right-hand side, detail W8, is the Carlsbad Municipal Water District detail for a mainline water connection. In our case, we called for 2-inch water lines to be tapped into the mainline per that detail, and then metered by Carlsbad Municipal Water District per the detail to the immediate right, detail W4. The sanitary sewer systems for the buildings were also designed, and demand was determined by district standards. The dry utilities consisted of the overall electrical design, including the building main power, parking structure main power, and the outdoor lighting elements. The water and sewer demands were calculated using district standards. For the sanitary sewer service, demand is based on 220 gallons per day per EDU. EDUs, or equivalent dwelling units, are the district's way of equating various types of properties. Per district standards, a commercial property is 1 EDU per 1,800 square feet of building space. After hydraulic analysis, 17,600 gallons per day called for 6-inch PVC gravity-fed laterals, 1 for each structure. The proposed water service design was calculated separately for each structure. For non-residential properties, average daily flow is 2,300 gallons per day per 10,000 square feet of building space. But the hydraulic analysis suggested that current 4-inch lateral and backflow preventer located just north of City Hall was a hair too small to maintain the required design standards, so a 6-inch lateral and backflow preventer were recommended. The proposed Civic Center and library buildings are well within the required design standards for max velocity, max allowable head loss, and minimum system pressure. Electrical design services were also provided for the project. Each building has an electrical room, including the parking garage. Transformers and public side conductors are to be furnished and installed by SCG&E at the city's expense. Included in the electrical rooms at the library and City Hall are lighting control panels. These panels receive a signal from the photocells located on top of 2 of the proposed lights, 1 for each circuit. The photocells act as a switch, completing the circuit when it becomes dark enough.